And we're live.
There we go. So this first question is a bit of a review from what we did last day. It says, okay, a person walks 6 kilometers north and 4 kilometers east. First of all, what distance have they traveled? Not displacement. What distance have they traveled? 10 kilometers. What's their displacement, magnitude, and direction? And what we want to do is we want to add these together. You know what? Since they've given me compass directions, I'm going to be smart and stick a compass rose somewhere on my diagram, just so I don't do something silly. Okay. McKinley, what's the first vector they gave me? The whole thing, magnitude and direction. 6 north, so if I draw that, probably looks like that. And plus, what's the second vector they gave me? 4, should I draw it as long, longer, or shorter than my 6? A little bit shorter, and east to the right. And for those 5 of you that were, 6 of you that were away last class, here is the key idea if you're adding vectors. How do I add 2 vectors together? Did you pick up the little mantra we've been doing? I draw them tip to tail. So here's what that looks like. Watch, 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 watch. Here's the 6. Here's the tip of the 6. I put the tail of the second one right there. You could also go the 4 first and the 6. You get the same answer. We'll do that in just a second. And then read, we said the resultant is from the tail of the first to the tip of the second. That's the, I'll call it D with a vector, displacement. Hey, how can I find how big that is? By the way, Jake, you're going to be getting an overdose of trig for the next couple of days, but at the same time, it'll be overlapping with both courses. Doing trig in my other math course right now, too. How can I find how big D is? Pythagoras, so I can go D squared equals 4 squared plus 6 squared, and then square root. Uh, 16 plus 36, the square root of 50, 7.1-ish, 7.0 something, 7.2? Now that's the magnitude. But what did it say in brackets? Magnitude and what? Now this is the trickier part. To find the direction, Rob, my friend, what I do is I go back to where my slanty vector started from. And that's where I put theta. Right there. Okay? The direction is going to be at, there's my at symbol. And then it's going to be so many degrees, something of something, north of south, east of west, something of something. The of something, the last part, that's going to be the vertical or the horizontal line that makes up the angle, not the slanty. What direction, Rob, is this vertical line right here pointing? It's going to be something of north. It's of north. Then I say to myself, self, starting on this line north, what direction do I go to get to my resultant? It's going to be east of north. And now I have to find the angle. I'm going really slow because this is a concept that kids really, really struggle with. In fact, one of my top kids about 9 years ago, brilliant student, he could not get this. Could not get this. He memorized all 16 possibilities. He memorized every one of what possible and memorized what they were because he just couldn't wrap his brain around how I was doing it. So I'm going slow on purpose. If you find this obvious, great. But I've learned over the years this is kind of a weird concept. How can I find theta? Opposite, adjacent. Which trig function? Opposite over adjacent. How can I find the angle? And this is why we did that trig review. Shift, and you'll have to put it in brackets. My calculator automatically opens up a bracket, so shift tan, and I think I said to you, Darian, it's usually going to be tangent, not always. There's going to be a couple of weird ones that we'll get into next class where it's not, and when we subtract, it won't always be tangent, but usually it will be shift tan of 33.7 degrees east of north. By the way, I'd take 34 degrees. In fact, usually I go to the nearest degree because 1 degree is only about that big. 0.1 of a degree, I'm really not even sure the human eye could spot that. Maybe, but you had a question, or did I answer it? I figured so. Darian, you could have, just to be different, you could have drawn the second vector first. You could have gone 4 and then 6. Do you notice I get the same looking resultant? Okay, and when I do the Pythagoras, I'm still going to get 7.2, but my theta this time would be of what? It's going to be something of, in fact, it's going to be north of east. How many degrees? Well, now that's opposite, that's adjacent. It's going to be shift tan of 6 over 4, which turns out to be 90 minus this angle. These two angles will always add to 90. There's a fancy name for that. They're complementary angles. I would also take 56.3 degrees north of east. I take both answers. But you have to have, with the 33.7, you have to have east of north, not north of east. And with the 56.3, you have to have north of east, not east of north. Okay, let's see some applications. A balloon is rising in the air at 8.2 meters per second. There's a breeze blowing due east at 2.2. Hey, I've seen this happen before. What's the balloon's resultant velocity, magnitude, and direction? Let's dulp. Let's dulp. Emma, what's the first vector they gave me? I have no idea what you said. Can you still understand? Can you speak a little louder, please? Did you say 8.2 meters per second? How would I draw that? Up? Okay. And now I'm going to have to be careful, folks. On the previous question, up was north. This time, up is up. Just saying, okay? So I'm going to go like this. 8.2 plus. Manny, what's the second vector they gave me? Direction? How would I draw that here? Yeah. Now, again, be careful. This is not north. This is, but okay. And I'll draw it about 1/4 as long as my 8.2 because it's roughly 4 times smaller. I've seen this before. By the way, right? What's going to happen is the balloon's going to be traveling this way, somehow, right? That's the resultant. Hey, Shaq, how would I add those two vectors together? Draw them. I don't know. Okay. No, not tail to tail. Absolutely never tail to tail. Jake, how would I draw those two vectors together? Draw them. Did you say tip to tail? I'd like you to look with a superior attitude down at Shaq and give a little, he was away. You know what? You know what? He was away. I was making him walk before he was starting to crawl. My fault. My fault. I'll never overestimate you again. So Shaq, here's what that means. What's the first vector they gave me? Read it to me. Pointing which way and the way I drew it? Up. There's the 8.2. Where's the tip? The top, the upper part? The tail of the second vector, except that's way too long. That's what we mean by tip to tail. The tail touches the tip of the first vector. And that's 2.2. Good, solve this on your own. Now, the direction, the what of what is going to be a bit tricky. Find the magnitude, find the theta, and then we'll say how the heck we would describe this. Do you get those two numbers? How could I describe this direction? I can't say north, because north is not up in this picture. Up is up. Here's what we would say. East of vertical. Vertical is a word that most of us know. Vertical implies straight up. East of vertical suggests, oh, start out going vertically up, go to the right. I probably won't give you one that vague on a test, except I will say a balloon in a breeze is a great example of vector mathematics, and you've all seen someone let a balloon go before, and you notice usually it travels slanty, not straight up. No, north is not up. I'm telling you, that's not north. I'd probably give you the marks, but I put a frowny face on there on the test because I'm fussy. I'm saying, you're telling me the balloon's traveling, that's north. Not. It's going up. By the way, in real life, in answer to your question, if you take first year university physics, to go three-dimensional, we talk about I, J, and K. I is left, right, J is up, down, K is towards you or away from you, and you can give any direction in terms of I, J, and K. 3I plus 2J plus 1K means 3 right plus 2 up plus 1 towards me. You just get you start thinking that way. Subtracting vectors. How do we add two vectors together? Draw them, tip to tail. How do we subtract vectors? Well, to be honest, the short answer is we don't. And what I mean by that, Atla, is there is actually a rule, and I used to know it. You drew them tail to tail, you did something else, and then you... Instead, we would rather use what we already know. How do I add two vectors together? Draw them, tip to tail. How can I turn a subtraction question into an addition question? Don't write this down. Instead of 5, take away 3. How can I write that as an addition question? I think you're right, but give me the whole thing. In other words, make that's not right. Add a negative. Okay, you just said make the 3 negative. To make it to an addition question, and I'm going to say instead of the negative, I'm going to use a word that begins with the letter O and rhymes with opposite. Okay, I'm going to add the opposite. Okay, what we're going to do instead is we're going to add we could learn, there is a rule for subtraction. It's fine. You know what? Why learn a whole new rule when I can just tie it into something I already know? In other words, if I want to go vector A minus vector B, instead, I'm going to go vector A plus negative vector B. And what do you think a negative vector would do? How do you think that would change the vector? The arrow is going to go to the other end. The magnitude won't change, but if it was pointing up and that way, now the negative is going to be pointing down and that way. It's a very easy fix. And then, hey, now it's addition. Add it tip to tail. So, if F1 is 6.8 newtons due west, better draw a compass. And F2 is 12 newtons due north. What's F2 take away F1? I'm not going to do that. F2 vector, take away F1 vector. I refuse to do that. Instead, I'm going to go F2. How will I change that minus sign? Plus the opposite of F1. And I always leave a bit of a space just to exaggerate it, Curtis, so that I know what I'm doing. F2. What's the first vector? Magnitude and direction. What's F2, Jeff? Magnitude and direction. Read.
12 newtons north.
Okay, so that's going to look like, and a 12 there, right? What's F1, the way they gave it to me in the question, magnitude and direction?
6.8 newtons due west.
So what would negative F1 be? Still 6.8 newtons, but due with authority, like in your voice, like you know you're right, like you're convincing the rest of the planet this is obvious. What would negative F1 be? Still 6.8 newtons, but instead of due west, it would be due?
East.
What if it had been due south, and it would be due?
North.
So due east, you know what? I'm going to go like this. Except that looks a little slanty, doesn't it? Sorry, guys. And I tried drawing it a little more than half as long. Again, do you have to draw these to scale, Valoria? No, but it helps. Roughly to scale. And can you see, Jeff, I've turned it into an addition question? Well, how do I add two vectors together? Why, I draw them. Tip to tail. So now, it's going to be 12 plus 6.8. This right here is F2 take away F1. Oh, let's do the Pythagoras. So it's going to be 12 squared plus 6.8 squared, and then square root. You get 13.8 for magnitude. Units, newtons. At, where is my vector starting from? Top right or bottom left? Look at my triangle. Where's my vector starting from? Top right or bottom left? That's where theta goes. It's going to be that angle there. Opposite, adjacent. Which trig function? Again. Tangent, again. (6.8 over 12). You get 29.5 degrees. 29.5 degrees. What of what? East of south, north of east, west of south, south of what of what? Well, here's the vertical line. This is going to be the of. It's going to be something of what? East of north. See it? Maybe you guys are getting this. Great. Or 90 take away 29.5, or 60.5 degrees north of east, and that would be that angle right there. I have to take both. Okay. So here's an application. Suppose an airplane is flying due north at 45 meters per second relative to the ground. If a crosswind is blowing at 12 meters per second due east, what direction is the plane pointing its propeller? Now, we did a plane question last lesson, and we said this. For any airplane, it's going to be the engine velocity combined with the wind velocity, the crosswind. That's what gives you what they see relative to the ground, what the control tower sees. I think I also went on a rant. I said, unfortunately, even though these are all velocities, pilots call it ground speed and air speed and engine speed, but they're vectors. They should be technically velocity, but okay, whatever. What does this question want me to find? Well, what has this question given me? What's that 45? It's a velocity. Yeah, which one? Tawny, read to me, my angel. It says an airplane is what?
Flying due north at 45 meters per second
Relative to the what? You know what? I think that 45 is what the tower is seeing. Keep going.
If a crosswind is blowing at 12 meters per second due east.
I think that 12 is that. Keep reading.
What direction is the plane pointing its propeller?
You know what? They want me to find the engine velocity, which is what direction, the propeller. How would I get this by itself? Subtract a vector. Ah, so if I hear you correctly, you're saying the engine velocity is going to be the ground velocity, take away the wind velocity. It's what you would do if it was normal variables. Except I don't subtract vectors. What do I do instead? So I'm going to go little plus sign, little minus sign right there. Okay. Anthony, what's the ground velocity, magnitude, and direction, please? You know what? I've scrolled down. I better do a compass rose. What's the ground velocity, magnitude, and direction, please, Anthony, my friend?
45 meters per second north.
Yoink. Plus, what's the wind velocity, magnitude, and direction according to the question?
12 meters per second due east.
So what would negative wind velocity be?
Due west.
12 meters per second still, but due west. 12, it's about 1/4 as long as 45 or so. Anyways, I think about like that-ish. Rob, have I turned it into an addition question? Oh, clever me. Any thoughts on how I could add those two vectors together? Before that, how might I draw them, Rob, my friend? There's a phrase I'm looking for. Oh, you do. You do. What'd you say, Rob? So it's going to look like this. Here's the 45. Yep, there's the 12. That's a little too short, I think, maybe. And the resultant is always from the tail of the first to the tip of the... It's going to be up and left, yeah? That there is going to be what I'm trying to find, which is the engine velocity. Good. Try this on your own. I'm going to freeze the screen. Try doing the Pythagoras, do the theta, and see if you can get the what of what. Does this work out evenly? That'd be a fluke. Oh, no, it doesn't. Yeah. No, yes? Yeah? Okay. 46.6 meters per second. By the way, Manny, this is actually a much more useful question because in real life, if a pilot knows where it wants to end up and it knows the crosswind, what the pilot has to decide is, how will I point my plane? Put your pencils down. Turn the page. We've been adding vectors tip to tail to get slanties. And now what we want to do is reverse that process. It's called vector components. We can break any vector up into its vertical, and we'll use the letter Y as our abbreviation for vertical, and horizontal, and we'll use the letter X as our abbreviation for horizontal components. Show you what I mean. It says, find the vertical and horizontal components of this vector. So if an object is traveling at 38 degrees above the horizon, 42 meters per second, we can break this up into up, down, and left, right by adding some lines like this. Draw that in. And we call this Vx. X for horizontal, V for velocity because it's meters per second. And we would call this V what? Why? Because I asked you to. Why? Because I asked you. Okay. And we can find the components of that. And this is actually going to be really handy, in fact, in Physics 12 and for the rest of this year. If they give us, Emma, something slanty, we're going to refuse to deal with it. We're going to say, you know what? Anything slanty is actually moving sideways horizontally and vertically at the same time. I'll break it up into its components, and I can look at each one of them on its own. What do you want to find first, Vx or Vy? Doesn't matter. I heard Vx. Okay. First of all, that 42, opposite, adjacent, or hypotenuse? What about Vx? Okay. Which trig function? So the cosine of 38 is adjacent Vx over 42. How would I get Vx by itself? Okay. Vx is going to be 42 cos 38. $33.1. Dane, you said we also could find Vy. Vy, opposite, adjacent, or hypotenuse? Opposite. Which trig function? Now, Manny, I could use tangent, but if I used tangent, I'm using Vx to find Vy, which means if I got Vx wrong, I'm guaranteed to get Vy wrong. So it'd be much smarter if I used those two. Which trig function would I want to use here? Sine, you say? How would I get Vy by itself? In fact, it's very similar to the Vx procedure. Except instead of cos, it's sine. Instead of cos, it's sine. You might be able to just backspace and edit on your calculator if you're lucky. Less typing. And I get 25.9. Now here's what we're saying. Shaq, moving at an angle of 38 degrees above the horizon, or above the horizontal, if we want to be really, really fancy, at a speed of 42 meters per second, that's the same as traveling to the right at 33.1 meters per second, whilst at the same time simultaneously traveling up at 29.5 meters per second. We can break any slanty velocity, Kyle, into its vertical and horizontal components. Big deal. Huge deal, actually. Find the components of this force. Okay. Well, again, Curtis, I'll use X for horizontal, but it's a force. What would be a good letter to use for force instead of V? What would be a good letter to use for force instead of V? F and F. Why? What do you want to find first? Fx, horizontal, or Fy, vertical? Doesn't matter. Fy, Darian says. So Darian, Fy, opposite, adjacent, or hypotenuse. And that 39.6, which trig function? How would I get the Fy by itself? FYI. Oh, yeah? No? Okay. So the FYI on Fy is 39.6 times the sine of 18. 39.6 times the sine of 18. 12.2 newtons. You could call it negative, I guess, if you wanted to call it downwards, or you could say south or down or something. But anyways, I got the magnitude. Hey, let's find the horizontal component. FX. A TV network. FX, opposite, adjacent, or hypotenuse. Adjacent. Which trig function? Now, I could use those two, but then I'd be using Fy. I could use tangent, but I'd be using Fy to find Fx. That'd be silly. I think I'd be much more clever if I use those two. Which trig function? Cos. What always goes next to the trig function? The angle. And that equals Fx over 39.6. How would I get the Fx by itself? Hey, Mr. Dueck, this is looking really, really similar to the Fy. Yeah, it is. Oh, you know what? I could have just gone backspace and changed the sign to cos. 37.7 newtons. Right. I can break anything into its horizontal and vertical component. By the way, what if I gave you something like this? Straight up. What's the vertical component? 12 meters per second. What's the horizontal component? It's a trick question. 0. Okay, that's perfectly acceptable too. Why are components so handy? Because they can help us add vectors that are not at right angles with each other. Yucky ones. Now, let me just think here. I got 20, I'm going to get this one. I'm going to get that one. I think I'm going to go like this, actually. I'm going to pause here and I have some homework for you. Give me a second. So take a look at the sheet that I just gave you. Looks like, I think it's vector additions. Nope, vector additions, this one, right? So it says add the following displacement vectors. Number 1 should be not too bad. When you get to 1G, here is 3 vectors. Hey, this is an awful lot like number 4 from the homework from last day. Add the ones that are in the same axis first, and then add that answer tip to tail to the next one. Same with H. And then on the next page, now you're finding the XY components of the following displacements. So it has 16 meters north, 16 meters, 27 degrees east of north. Draw the vector first, it really helps, and then find the components. And this is also practice in drawing these pictures correctly. 20 meters, 52 degrees west of north. 10 meters, I always have to remember. Can you look at D where it says 10 meters, 327 degrees? This is really going to be, it's a bearing of 327 degrees, Mr. Dueck, and bearing is counterclockwise. It's going to be 360, take away 27. I think it's going to be at 33 degrees. So cross out the 327, and instead it's 10 meters at 33 degrees south of east. Now you can do D. You can do 2A, 2B, 2C. You can't yet do D, and the reason is, this is what we're going to pick up with next class. Now you're adding a slanty vector in. So you can get up to there done today. Don't hand it in. We'll pick up with this next class as well. Okay?